Moving on to vector addition. If I know how to add two vectors now, if I have the vectors written as arrows, I know how to add those, right? If I have a diagram, okay. Let's see how we add vectors now if we have components, okay. So if I have this this vector A, and it's written in terms of in component form, and so this would be A1, this would be A2. This component here would be B1, and this component would be B2. All right. Well, if I add A and B together, that's this red vector here. So what would the total? What would the components of this vector be in terms of these four variables? Well, the x component of this big red vector, assuming this is a vertical line, okay, it doesn't look very much like a vertical line, but it would be A1 plus B1, right? So for the x component, it would be A1 plus B1, and for the y component, it would be A2 plus B2. That's really nice, okay? So it's really just a little bit of arithmetic. All I have to do is I take the components of my first vector, add it to the components of my second vector, okay? And then this is the resultant vector, okay? So let's do an example. What is the vector A plus the vector B if vector A is 2, 5 and vector B is 1, minus 3? Okay, again, very, very easy. I'm just going to be adding these two numbers. So it's going to be 2 plus 1 and 5 plus minus 3. Okay, 5 plus minus 3 is just that, right? So I end up with 3 and 2, and there you go. That's the vector A plus the vector B. Okay, so vector addition is very easy. Just add components. All right, components. All right, what about negative vectors? Okay, moving on to negative vectors. So vectors are negative, we know, if they have the same lengths, but they're just flipped. They're just going in opposite directions, right? So what does that tell me about my components? We did this in the previous example. We did that in this example right here, didn't we? Where we said what's AB and what's BA. We noticed that the components of this is positive and the opposite has negative components. So that tells me that if vector A is A1, A2, then the opposite of that vector, the negative vector of that, would be minus A1, where that's a number, and minus A2. Okay, so notice here this rule, and this is going to be useful later on when we do subtraction. Okay, all right. Vector subtraction. A minus B is vector A plus the negative of vector B, right? So we're just going to do addition again. So what I do now is if vector A is this and vector B is this in component form, I'm going to take this, make it negative, and add it to this. And so we end up with A1 minus B1, A2 minus B2. Okay, so if I have these two vectors, then A minus B is going to be this. Now, notice here that this is a difference, so it does matter which number goes in front. This number should always, the number that I'm subtracting from should have its components be in this column here. Okay? Let's do a quick example. Whoops. Let's do a quick example here. If P is 3 minus 2 and Q is 1, 3, what would be P minus Q? Okay, I'm just going to take my P components and take away the Q components from it. So it's just simple arithmetic. 3 minus 1, minus 2 minus 4. We end up with minus 2 and minus 6. All right? So there you go. That is how you find the the difference of two vectors. All right? Now, please don't confuse, okay? Please don't confuse this process here. So let me write a note here. Don't confuse this. This is vector subtraction, okay? This is vector subtraction. Okay, don't confuse this with finding the vector of a point. Finding the vector between 2 points. Okay, between 2 points. Okay, when we're finding the vector between 2 points, we are actually taking b minus a, right? So it's separate. We take the coordinates of b, and then, you know, if I'm looking for this, then I do, if this was b1, b2, this was a1, a2, this would be b1, b2 minus a1, a2. All right. So this is when I'm finding a single vector between 2 points. This is when I'm finding a vector, a resulting vector, the resultant vector when I take a difference of 2 vectors. Okay. So this notation might be a little bit confusing. Okay, but please be careful that these are 2 separate things. Okay, this is finding the vector between 2 points, and here we're doing vector subtraction. All right. Okay, last thing for this section on component form. You should know how to find the magnitude of a vector. What was the magnitude of a vector? Well, that really was just the length of the arrow, right? So, can I find the length of a vector if I've been given the vector in component form? The answer is yes, because I know the components. And remember, the components are arranged so that the triangle that's formed is a right triangle. So we just use the Pythagorean theorem, and so this becomes my x value, this is my y value. So the magnitude, remember this is how we notate our magnitude. The magnitude of a vector is the square root of a1 squared plus a2 squared. Okay, so that's the magnitude of a vector, very important. And here's an example. If I say find the length of this vector, this is not a point, okay, this is a vector. What I need to do is I need to take the magnitude, let's say this is vector A, okay? Well, the magnitude of vector A then would be the square root of minus 4 squared plus, because it's Pythagorean theorem, it's not a distance formula. Well, it is. Minus 4 squared plus 3 squared, and we end up with 16 plus 9 square root, and we end up with 25. Square root of 25, which is just 5. Okay, and that makes sense because that would be a 3, 4, 5 triangle, right? 3, 4, 5. Okay, so you should probably be very familiar with that. All right. Okay, so that's it for this video. Now we know how to do all of the operations with vectors that are in component form. Okay.